Lesson 11.2 is on rational functions. In this video, you will learn to identify excluded values and identify and use asymptotes to graph rational functions. Okay, so your vocabulary for this section is rational function, excluded values, and asymptote. Okay, a rational function can be described as an equation of the form y equals p over q, where p and q are polynomials, and q is not equal to 0. So the parent function would be 1 over x. And this is the type of graph, it's called a hyperbola. So this thing where you have like these two graphs that have these asymptotes and things, those are called hyperbolas. Okay, and the domain and range is all values except for 0, and the range is also all values except for 0, because there are asymptotes there. So first thing we want to learn how to do is to find excluded values. So the excluded values are when the denominator is 0, because we can't divide by 0. It would be undefined. So we set our denominator equal to 0, and then we can figure out when it's going to be 0. So when x is 0, this is undefined. So my excluded value is just 0. Okay? The next one, it says state the excluded value of this one. So this whole denominator, this can't be 0. So that means x plus 2 it can't be equal to 0. Oh my gosh. Okay, sorry. I think I was being uphill. Anyway, so x plus 2, we set it equal to 0 to figure out what value is excluded. And then I solve for x. So I'm going to do minus 2 from both sides, and I'm going to get x cannot be equal to negative 2. So my excluded value is negative 2, because if I put in negative 2, I get 0 in the denominator, and we can't divide by 0. So same thing, we're going to take the denominator and set it equal to 0 and solve for x. So I'm going to do minus 1, I get 2x equals negative 1, so x is going to be negative 1/2. So that's my excluded value, negative 1/2. Okay? So you guys find an excluded value for these. Okay, the next thing we want to be able to do is to graph this. So if X students will compete in a talent show lasting 100 minutes, the function 100 over X represents the number of minutes available for each act. Graph this function. Now, because we're talking about minutes, we don't need to do both. We just need to do positive values. So if I'm going to put my minutes down here, and then I can, let's say, go by 20s. Okay, sorry. So the students go on the x-axis and the number of minutes because it said x represents the number of students. Okay, and y would be the number of minutes. So if I were to graph this, I would make a table of values and I would say, okay, if I were to put in 1, how many minutes would be available? So 100 divided by 1 would be 100. So I can plot the point 0 for 1, 100. If I were to put it in 2, I would have 50. So at 2, it's going to be at 50. If I put in, let's say 4, it's going to be 25. If I put in 10, that's going to be 10. So at 10, I'm down to 10. So this is going to be my graph when I do this. Okay, that's the function. And if you were to draw theirs, they're looks a little nicer. Okay, so you guys say which one of these is the graph for 300 divided by x. All right, asymptotes. So a rational function of the form y equals a over x minus b plus c has a vertical asymptote at the value x value that makes the denominator equal to 0. And it has a horizontal asymptote at c. Okay, so that could make it easier to draw our graphs. So if I have this here, the value that is underneath here, that's going to be my vertical asymptote. So when x is equal to 0, in this case, whatever the denominator is, set it equal to 0 and solve. It's already solved. That's going to be my vertical asymptote. So I can draw my vertical asymptote at 0. Usually I draw a vertical asymptote with a dotted line. Okay? And then it said that for the value that's being added or subtracted to the rational function, that is my horizontal asymptote. So that means at -4. So horizontal asymptote, or y equals -4. So I can draw that down here. Now, I don't have any negatives on this graph, so that means it's just going to be regular. My graph is going to be doing like these swoopy things in here and down here. Okay, and if you wanted to get a few values, you could. I drew this one really bad, so it's not going to work. But if I would put in like 1, 3 over 1 is 3, minus 4 is -1, so I'd have the point 1, -1. So it's a little bit lower than I had drawn, but you get the idea. Okay? And so you get this graph here. Okay, so if I want to identify the asymptotes for this and then graph it, so remember my vertical asymptote is when the denominator is equal to 0. So I'm going to do x plus 2 equals 0 and solve for x. I do -2 and I get x equals -2. So at -2 is a vertical asymptote, means it goes up and down. So that's going to be here. Okay, and then I want to find a horizontal asymptote. I'm not adding anything. So I can think of it as if I'm adding 0. So it means my horizontal asymptote is at 0. So my graph is going to go here and here. Oops. Okay. So you guys should find the asymptotes for this one, the horizontal and the vertical, and graph it. Okay, so key concepts is the family of functions. So we learned quadratic, we've learned exponential, we've learned radical, and now we've reached rational, which are these like swoopy hyperbolic things. And that is the end of lesson 2.